All right, everybody, we are going to move on to our next unit that deals with the mass in the mole. The other day we went from mole to particle. Now we're going to add mass into it. So let's get going. So just a general introduction here as far as mass goes. And it says, would you expect a dozen limes and a dozen eggs to have the same mass? Obviously not, because they're two different things and they're composed of different compounds. And they're different sizes, so they definitely have different masses. All right, so 1 mole of two different substances has two different masses, and we're going to rely a lot on our molar mass, so you should have a periodic table of elements with you when you're doing these types of problems. And one last thing down here, the atomic mass, its units are gram per mole. And again, we can find these on the periodic table for any element. All right, so let's start by looking at how to figure out the molar mass of either an element or a compound. So in the top half here, we just have a couple different elements. So number one, we have Fe, which is iron. So all you need to do is look on your periodic table and find the molar mass of iron, which you can see is 55.85 grams per mole. For number two, we have mercury, which is Hg. And if we look that one up, we see it's 200.6 grams per mole. The third one, we have Cu plus 1. Now the plus 1 represents an ion, but it's not going to affect its molar mass. We haven't gotten to ions yet, but we'll talk about that further down. So just look up the molar mass for Cu, which is copper, and you get 63.55. Now for the bottom half here, we have compounds. So you're going to have to add them all up. So you have H2O2. That means you have two hydrogens and two oxygens. So what I have is I have 1.01, which is the molar mass of hydrogen, multiplied by 2, plus 16, the molar mass of oxygen, times 2. And you get a total of 34.02 grams per mole. In number 2 here, we have aluminum hydroxide, and we have a 3 outside the OH ion. So aluminum is by itself, so we just look up the molar mass for that. Now the 3 distributes to both the O and the H. So remember, there's imaginary ones behind the O and the H, so you take 3 times 1 to both of them, so you have 3 of each. So again, the 26.98 goes with the aluminum. 16 is the molar mass of oxygen, and I multiplied it by 3. And 1.01 is the molar mass of hydrogen, and I multiplied that by 3. Add them all up, and you should get 78.01 grams per mole. For the third example here, we have magnesium phosphate. Now, I suggest you pause the video and try to solve this one on your own, and then unpause it and see if you got the same thing I did. So for this one, it's exactly the same as kind of the problem above it. We have magnesium, we have 3 of those. The 2 outside the phosphate ion there, the PO4, that 2 gets distributed both to the P and the O. Remember, it does not go to the magnesium. So we have 3 magnesium, so 24.31 times 3, plus 2 phosphoruses, which is 30.97 times 2, plus 16 times 8. 16 is oxygen, and there's 8 of them. So remember that 2 goes to the phosphorus to give it 2. 2 times 4 gives us 8 to give us the total number of oxygen. Add it all up, and you should have gotten 262.87. Now I know this seems very simple because all you're doing is adding up the numbers, but a lot of times people miss these problems. Either they're careless and they just try to add it up too quickly, or they forget one, or they don't understand how to distribute those numbers outside the parentheses. So take your time and double check your answers. All right, so now we're going to convert moles to a mass. It says, suppose while in a lab you need 3 moles of copper for a chemical reaction. How would you measure this amount? Does the balance allow you to measure in moles? Of course not. The balances that we have in our class only measure in grams, so we have to figure out how many total grams we have. Now the conversion factor here that we have is 1 mole of any substance equals the molar mass of that substance in grams. Now remember that 1 mole of hydrogen is completely different in mass as 1 mole of oxygen, okay? Because remember, they have different masses. But 1 mole of anything equals the molar mass of whatever element or you have on the periodic table. So let's look at our conversion. We have 3 moles of copper that came from the problem. And in our second step, we do our conversion. So remember, when you're setting up these problems in your T-chart, the thing that's written in the problem always starts in the top left. The second part of the T-chart comes from a conversion factor. So 1 mole equals the molar mass. So the molar mass here of copper is 63.55. Multiply it out, and you end up with 190.65. If I go back and I do my correct significant figures and my unit, I end up with 191 grams of copper. All right, here's some more practice. We're going to do a lot of this because the only way to get better at it is to do continuous practice. So we're going to determine the mass of 3.57 moles of aluminum. So again, that's what we're starting with. Start that with your top left-hand box of your T-chart. The second step is our conversion. 1 mole of aluminum equals its molar mass, the 26.98. And remember, I just pulled that off the periodic table. That's not coming from anywhere else, just the periodic table. Multiply it out. You should have gotten 96.3186. Again, significant figures matter. I end up with 96.3 grams of aluminum. Again, I would pause the video, try to do number 2 on your own, and see if you get the same thing I do. So for number 2 here, it says how many moles are in 12.5 grams of NaOH. So this time we have a compound. So start with our mass. In this case, again, we're starting with our mass. So that means the thing in the bottom we have to cancel out is a mass. So the 40 comes from the NaOH. Na is 22.99, O is 16, and H is 1.01. So that's how I got 40. I just added them up. So 12.5 grams divided by 40, solve it out. You should have gotten 0.3125. Again, significant digits, 0.313 moles of NaOH. All right, here's some more practice examples. Again, I suggest you pause the video and try to do these on your own, and then unpause it and go back just to make sure you did the same stuff I did. So let's take a look at number 1 here. It says, determine the mass of 6.78 moles of copper 2 sulfate. So again, that's always what we start in our left-hand box for a T-chart. Again, I added up the copper, the sulfur, and the 4 oxygens, and I ended up with 159.62. So again, you see moles cancel out with moles, and I'm left with grams. Multiply it out, you got 1082.22. You need 3 significant digits, so it ends up being 1080 grams of CuSO4. For number 2 here, it says how many moles of calcium nitrate are in 1 kilogram of calcium nitrate. Now, in this problem, it gave me 1 kilogram of calcium nitrate. Before you can start solving this problem, you have to convert that to grams. And the reason you got to convert that to grams is because all the masses on the periodic table are all in grams. So a common mistake. Doing things like that by changing the units, that's how I kind of trick you and mess you up on these problems when you do them on a quiz or a test. So let's take a look here. We first start by converting 1 kilogram of our calcium nitrate to grams. So we know that there are 1,000 grams in 1 kilogram. Then our next step is to divide out by the molar mass. I have 1 calcium, I have 2 nitrogens, and I have 6 oxygens, and I added them all up, and I got 164.1 grams. Go ahead and solve that out, and you should have got 6.093. Again, I have to have the correct number of significant digits, and I have 6.09 moles of the calcium nitrate. Now, what does this all mean? We saw the other day that 1 mole equals 6.02 times 10 to the 23rd particles of any substance. And we learned today that 1 mole equals the molar mass. So essentially what we can say is 6.02 times 10 to the 23rd particles equals the molar mass of the substance. Now, me personally, I like to go step by step by using that mole road map that we've seen before or that I handed out to you. You don't have to. You can easily set up that says 6.02 times 10 to the 23rd equals the molar mass, but me, I like to go step by step. So of course, we've got some more practice here. Let's go through the first one together. It says a sample of Si has a mass of 4.56. Determine the number of atoms in the sample. So we're starting with mass and we're trying to get to atoms. If you're using your mole road map, you see you're starting at the very bottom. Then you have to stop at moles, then you go to particles. Okay, so taking a look here, I have 4.56 grams of Si. I'm going to divide it by its molar mass to give me moles. Then I'm going to convert moles to atoms. So again, the top left box is what you have. The second box, the 1 mole over Si, is 28.09. That's 1 mole equals the molar mass. And the last one, 1 mole of Si, equals 6.02 times 10 to the 23rd. 1 mole equals particles. Okay? So all I did was do it step by step. Yes, you could essentially say 4.56. Then your next box would be 6.02 times 10 to the 23rd atoms over 28.09. But again, I like to go step by step. That's just how I've always done it, and that's how I'm going to continue to do it. When I solved that out in my calculator, I should have gotten 9.77 times 10 to the 22nd atoms of Si. Again, I suggest you pause the video and try to do number 2 on your own. And then unpause it and check and see if you got the same thing I did. For number 2 here, it says determine the mass of 3.45 times 10 to the 14th atoms of Fe. This time we're starting with atoms, so we're just kind of working in reverse. So taking a look here at the setup here, I have 3.45 times 10 to the 14th atoms of Fe. I'm going to divide that by the number of particles, which is that 6.02 times 10 to the 23rd. Then I'm going to take my moles and I'm going to convert that to grams, and that 55.85 just comes off the periodic table for iron. I solve it out and I end up with 3.20 times 10 to the negative 8 grams of Fe. Again, using that mole road, you can see step by step as far as where you're supposed to go. That should help you when you're solving these problems out. Alright, taking a look here at our very last problem, we have the aluminum chloride. It's used in refining of petroleum and manufacturing of rubber and lubricants. So a sample of aluminum chloride is 35.6 grams. How many formula units of aluminum chloride are present in the sample? So when we solve this one out, we're starting with a mass. Again, we're going to divide that by its molar mass, which is 1 aluminum plus 3 chlorines. That's how I got 133.33. Then I'm going to go from mole to formula units. Formula units is the type of particle. So I've got to multiply by that 6.02 times 10 to the 23rd. Solve it out. I end up with 1.607 times 10 to the 23rd. Again, going to significant digits. 1.61 times 10 to the 23rd. Formula units of aluminum chloride. Again, the more you practice this stuff, the easier it will become. Right now, it might be a little confusing. But again, go back through this, understand why we're setting up the T-chart the way we are. Make sure your units cancel out. If your units aren't canceling out, meaning one's in the top, the opposites, the same thing's in the bottom, then we're doing something wrong. So go back and take a look, and hopefully it will make a little bit more sense.